So my name is Roberta Sinatra and I'm a postdoctoral research fellow at Northeastern. And I will talk about the story of your big hit, but I want to start with the story of one big hit. And the one big hit I'm talking about is the discovery of penicillin done by Alexander Fleming a little bit less than 100 years ago. And Alexander Fleming discovered penicillin by chance. He forgot a petri dish for 2 weeks, and when he came back, he found this fungus on it. And people debate whether it was just luck or not, because still you need Alexander Fleming to look in a contaminated petri dish. So is, like Alexander Fleming, your success random? I mean a scientist. And by success in this case, I mean a big achievement, a big discovery, so a high impact work, a hit. And some insight into this matter can be given by citations. We have seen that citations are a good proxy for scientific impact. In this work, what we study is 100 years of physics. We have all the papers, all citations, and all unique authors that publish in American Physical Society journals. So we have under control the diffusion of credits and the impact in one research field. And this is how we depict career. So we have time on the x-axis, and each of that red lines is a paper. And the height of the paper is a measure, corresponds to some impact. As you see, in this case, Kenneth Wilson has a huge hit at that time, and that is the work that, thanks to which he won the Nobel Prize. In each career we can find a hit, we can see a paper which is outstanding, and this is where the story of your big hit starts, and I will tell it in 3 chapters. So, first chapter. So from our experience, we expect something like this for impact, that it increases, we learn, then we reach a star, a wonderful thing, and then goes a little bit down but stays on a plateau more or less. Instead, surprise, this is what happens when we look in the data. So impact is flat before you hit, then you have a sudden finger, and then it's flat again. So it seems to be quite random. And this is what we learned from chapter 1. We do not see the hit coming, nor we do learn from it. However, if we look better in these careers, in this time series, we see that indeed there are some correlations. So we take the career, we identify the star, the hit, and look at the average impact before the hit and the average impact after the hit. If we correlate the height of the hit and this average before and after, we see that there is some correlations. Left is before and right is after. And this wouldn't happen in a random process where I attach randomly impact to papers. So chapter 2, the higher was our early impact, the larger is the magnitude of the hit. And we want also to understand the effect on productivity, because even in a random process, if you publish more papers, if you have longer sequences, the highest hit will be bigger. So we can use this null model where we can look at the same thing in the data. So correlate the hit with the number of papers you publish. And as you can see, what happens in the data, so in reality, is that you learn more than in a random process for each paper you publish. So the more papers you publish, the higher is the impact of the hit, and this is not a random process. And last thing of chapter 3 is the following. Productivity is different if you have a bigger hit or a smaller hit. So productivity increases, is more pronounced for bigger hit and stays on a plateau which is higher than a small hit. And here what we are looking is number of papers published per year. So our experience suggests this, that we learn, our impact increases and stays on a plateau, but what we see is a finger, so it's sudden. Instead, what we have to look at is productivity, so how much we are publishing, and that gives a better hint of what's going on, or what matters for this process. So, thank you. It was too fast. I would like to thank my collaborators, and we have another event that's already advertised in Barcelona. We have a call open for that, so please submit. Thank you.